Hey 8th graders, today we're going to be doing a solving equations review just to kind of review and remember all of the skills we've learned so far in the past 2 weeks. So I'm going to do 3 of these problems on your note sheet in this video, and then the other ones I'm going to have you try on your own, and then we'll go over them during our Google Meet time. So this first one, -3 times 2n plus 1 plus 7 equals -5. The first thing you want to do with any equation is to scan it and see if there's any places that you might need to simplify. So I see a parentheses, that means I need to distribute. So I'm going to distribute this -3 to the 2n and this -3 to that +1. Well, -3 times 2n is a -6n plus, well, -3 times 1 is -3. And then I'm going to drop down everything that I didn't use. So that +7 equals, and that -5. Now that I've distributed, I'm going to scan my equation again, see if there's any other things I could simplify. I'm noticing that there's 3 terms on my left side. Usually when there's more than 2 things on one side, you need to simplify. So I'm going to see if there's any like terms I can combine. Well, here's a variable term, here's a constant, and here's a constant. So it looks like I can combine those constants. So -3 plus 7 is, let's see, 4. And I'm going to drop down that -6n and that plus sign. I'm going to drop down the equals -5. And I'm just going to do one last scan. Is there anything I can do to simplify this? And there is not anything. The 3 things that you could possibly need to do to simplify would be things using PEMDAS, combining like terms, or distribute. I'm not going to throw any other things at you besides those 3. So again, I made my T-chart. Make sure to do this to stay organized. I want to solve for n, so n is right here, that's my variable. And what's in the way of n being by itself? Well, this -6 and this +4. Well, who is the best friend? The best friend is going to be 6, right? Look at how close they are. Or sorry, excuse me, the -6. Since -6 is my best friend, I'm going to get rid of the 4 first. That is a +4, so how do I get rid of +4? I'm going to subtract 4 from both sides. So -6n plus 4 minus 4 is -6n, and -5 minus 4 is -9. Now, just that -6 is in the way of n being by itself, how do I get rid of the -6? Well, it's -6 times n, so I'm going to divide by -6 on both sides. So on the left, I'm just left with an n. On the right, I'm left with 9/6, which is equal to 1.5 or 1.5. So my answer is n equals 1.5. Let's try another one. So 2x minus 3 times 4 equals 4. Well, it looks like there's kind of a lot of stuff going on the left. Again, we're going to scan it. We notice a lot's going on. Let's see if we can simplify it. Well, it looks like in this left side, in this expression, there's a subtraction problem that's going on, and there's a multiplication problem that's going on. Well, PEMDAS, right, says that you multiply and divide before you add or subtract. So I'm actually going to do this multiplication problem first. So 3 times 4 is 12, and then I'm going to drop down everything I didn't use. So that 2x and that minus. Same with that equals 12. Or sorry, equals 4. Now that's a more manageable equation. Let's make our T-chart and let's solve. So 2x minus 12 equals 4. I want to isolate that x. Well, what's in the way of x being by itself? 2 and that minus 12. So who is a best friend to x? Our best friend is 2, so I'm going to get rid of the minus 12 first. How do I get rid of minus 12? I'm going to add 12 because that would be my inverse operation, the inverse for subtraction. So on the left, my 12s cancel out, and I'm just left with 2x. And on the right, well, 4 plus 12 is 16. Now, what's in the way of x being by itself? It's just that 2. And how do I get rid of that? Well, it's 2 times x, so I'm going to divide by 2 on both sides. So I'm left with x equals, well, 16 divided by 2 is 8. So x equals 8 is my answer. The next two I'm going to have you try, and then we'll go over them in class. We're going to do this word problem. So George makes a $1,000 down payment for a car and then pays $325 per month. Elaine makes a $2,500 down payment for a car and then pays $325 per month. Is there any number of months after which both George and Elaine will have paid the same amount? Well, what's my problem that I'm trying to answer? Is there any number of months after which both George and Elaine will have paid the same amount? What is my key information? Well, George made a $1,000 down payment and then pays $325 per month. I'm going to kind of underline George in blue. That's his information. I'm going to underline Elaine in green. And she paid $2,500 for a down payment and $325 per month. Well, if I want to answer my question, I want to know if George, right, the amount George paid is equal to the amount Elaine paid for some month, right? We want to know if there's ever a time where the amount George paid is equal to the amount Elaine paid. That would be the same as saying they paid the same amount. Well, how much does George pay? Well, he paid $1,000, right, as his down payment right away. And then every month he paid $325, right? So he paid $325 the first month, the second month, the third month. Well, we want to know, right, after any number amount of months, right? So we have to give months a variable. Let's make it M. So months equals M, right? So we can remember it. So the amount George paid would be $1,000 plus $325 every month. And the amount Elaine paid would be, let's see, she paid $2,500 for a down payment, plus she pays $325 every month. We want to see if those two are equal. So let's solve this equation for M. Well, I'm going to make my t-chart. I'm going to notice that there's variables on both sides. So I'm going to go through it and I'm going to just highlight what are my variables and what are my constants. Well, 1,000 is a constant and 2,500 is a constant. And 325M and 325M are constants. So that means that I can pick what side I'm going to put my constants on and what side I'm going to put my variables on. So when there's constants and variables on both sides, I like to always put my constants on the left and my variables on the right. And that's just a personal preference. I think it works out a little bit easier if you do it this way. So let's see. I want my constants to be on the left. Oh, I wrote my things in the wrong color. Whoops, constants I was supposed to write in blue. Variables I was supposed to write in red. There we go. So I only want constants on the left. Well, 1,000 is a constant, it's in the right spot. But that 325M is not in the right spot. So I got to get rid of it. How do I get rid of it? Well, it's plus 325M, so I'm going to subtract 325M from both sides. So I'm left with just 1,000 on the right and just 2,500 on the left. Well, 1,000 equals 2,500. That's a false statement. So there's no solutions. So I'm going to say that there is never, let's see, a number of months after which George and Elaine will have paid the same amount because let's see, the equation that represents this solution, this situation has no solutions. Thank you for watching this video. Make sure that you try out the other two problems.